that halide as one product from here. And that halide as another possible product from there. Are there any of those four products that you think might be formed in greater yield than any of the others? Samir?
The most substituted product, just because.
All right, let's call this A, B, C, and D. So which one do you think that is, Samir?
A.
This one?
Just because that bromine, when you make that radical during when you make those resonance structures, that radical electron, that one electron is also stabilized by hyperconjugation. The electron donated effects of that metal.
Right.
So I would think that's one of the most resonance contributing. That's one of the more major resonance structures. And so there's a stronger likelihood that bromine is that product.
Right, so what Samir is saying is that when you form this tertiary radical, a tertiary radical is more stable than a secondary radical, right? Because this radical is stabilized inductively and through hyperconjugation by that methyl group. So of all the radicals that we saw, this is the most stable radical. So what Samir is saying, since that's the most stable radical, he thinks that this product that you get from that radical should be one of the major products of the reaction. And that would be true. Do you see anything else that might be, Karen?
And the more stable alkene.
Right, this one, B, is the more substituted alkene. So this alkene is di-substituted. There is a H and a H. This alkene is di-substituted. This alkene is di-substituted. But this alkene feels as if it has 1, 2, 3 alkyl substituents attached to the double bond. So based on Zaitsev's rule, right, that's the more stable of the alkene products, right? So you have one product formed because it goes through the more stable radical, and then you have another product that in its final state is more stable, right? And I'll leave you with just these terms for these. This product you would refer to as the thermodynamically controlled product. Meaning that when you talk about something being under thermodynamic control, meaning that if you do the reaction at a high enough temperature where any of the activation energy barriers could be overcome, right, then that's the product that would be most stable at equilibrium. So whichever is the final most stable alkene, that's the product that would be dominant at equilibrium conditions of higher temperature. Right? This product that comes from the more stable radical, we would refer to as the kinetically controlled product. meaning that under really low temperature conditions, then, you know, if we think about activation energies and stuff, the more stable radical would go through the lowest activation energy to form itself. And if it's the lowest activation energy, then it's the radical that's most likely to form at very low temperatures. So therefore, the product that you get from that radical is said to be under kinetic control, meaning that it is the product that you would form under very low temperature conditions. Okay. So we'll see when we pick up next time we have class, how if this is a reversible process, we might end up getting more of either the thermodynamically controlled product or the kinetically controlled product, depending on what temperature we run the reaction at. Okay.